everyone. Today we are going to see about the subject VLSI device modeling, which includes the team members Roshni, Vishnupriya, and Kurunji, and we are the team Satledge. And today I am going to speak about some interesting facts about the MOSFET and field effect transistors, which includes the literature review of this part. And first, we are going to see about many research papers, 6 different papers, and first of all, which includes the paper improved threshold string and the short channel effect in field effect transistor silicon on insulator n channel negative capacitance field effect transistor, which includes various different parameters such as negative capacitance, short channel transistor, ferroelectric hafnium zirconium oxide. And in this paper, the authors deal about different characteristics of current and voltage, which includes the drain current and gate voltage. That causes a rapid increase in the comparison of the graph as shown in the figure. Then we includes the design parameters such as electron beam lithography, sputtering, photolithography, X-ray diffraction. As we all know, these are the basic techniques to coat the substrate, which includes different efficiency modeling methods. And coming to the methodology, in order to calculate the negative capacitance FETs, which channel lengths from 30 nanometer to 50 micrometer gated with ferroelectric hafnium zirconium oxide are fabricated on fully depleted silicon on insulator substrates. Then coming to the comparison, as we all know, there is a huge comparison between drain current and gate voltage, and the characteristics graph will be explained on the front slide clearly. And the current includes of 10 to 11 ampere. Then we are going to some interesting paper which includes the negative capacitance of field effect transistor with hysteresis loop, and which includes the voltage of 60 megavolt per decade switching. In this, the parameters include capacitor, FET oxide, and insulating materials, which include rapid change in the graph. As we all know, there is a change between applied voltage and psi, which is nothing but Schrödinger wave equation. There is a huge change as we can be see in this graph. Then coming to the design parameters, the objective of this paper is to show that we are replacing the insulator with a ferroelectric insulator. This graph basically shows that the polarization variation and with the electric field. Hence, the value is lesser than 60 megavolt per decade. This can be understood by noting that ferroelectric capacitor is effectively a -1 because the slope of P versus E is a negative of origin. Coming to the methodology, ordinarily this negative slope segment is unstable and observed in various different experiments with the hysteresis loop. As we all know, the experiment can be clearly explained with the hysteresis loop. Then next, we are going to one different paper which will be explained by the my teammate Vishnupriya. Okay, coming to the different slides of comparison, we are going to see about simple technique for separating the effects of interface traps and tapped oxide change in metal oxide semiconductor transistor. The parameters of metal oxide is on our analysis via uniform doping intensity, a spreading resistance measurements is performed of MP channel and N channel transfer indicate the variations in doping less than the plus or minus of 20%, which includes the pre-irradiation subthreshold slope, and the technique which involves the measuring increases or shifts in the slope. Coming to methodology of this paper, interface traps in the upper half of the band gap are generally believed to the acceptors, and this mid gap to the threshold and become negatively charged. This has the stretching out the subthreshold current curve between the threshold. Then we are switching on to another paper of this topic, which includes the frequency dependent capacitance voltage characteristics for amorphous silicon based on metal insulator semiconductor structure, which includes FET and negative capacitance. As the graphs are shown below, we have undergone a different researches which includes the characteristics of this paper. In this, the designers are very effectively used and the modeling method is absolutely perfect. A design methodology of ferroelectric negative capacitance fields based on the concept of capacitance matching is present. Coming to the methodology, capacitance tuning to achieve the maximum enhancement of capacitance. This is tuned by changing the ferroelectric thickness of the material, which has the influence on the characteristics of NC MOSFET capacitors, which includes the TFE value of 150 nanometer, and the Q versus VG curve has two different types, but this has a huge effect in the hysteresis loop, which will be explained in the slide of before. Next, we are going to see about another one more different paper, which will be explained by my teammate Kurunji.
Now we are going to see about evaluation and optimization of short channel ferroelectric MOSFET for low power circuit application with BSIM4 and Landau theory. Here are the parameters. Parameters are a FET ferroelectric inverter. Here you can see the graph how it goes. The design of this paper is like as if feature size scales down in MOSFET, the rapidly increases power consumption has become a severe issue that slows down the integration density of transistors on a chip. The key to Hysteresis-Free FET design, which is required for analog and digital applications, is capacitance matching. Positive capacitance of intrinsic MOSFET below, the ferroelectric should stabilize with negative capacitance. The methodology of this paper is like the voltage transfer curves of ferroelectric inverter. An intrinsic inverter without ferroelectric, because FET is designed as a low power device, VDD is selected at 0.5 volts and 0.2 volts. It can be seen that the two VTCs of ferroelectric inverter are almost the same, with a similar maximum gain at the switching voltage of VDD by 2. Compared with the intrinsic inverter, it gains the smaller and the static noise margins NML and the NMH strings. Now we can see the next paper, the same like all this, but it's still interesting. Ferroelectric negative capacitance MOSFET, capacitance tuning, and antiferroelectric operation. Parameters are TSAT, Synthesis software, NCFET, hysteresis loop. Here you can see the graph how it goes and the structure of this mission. Now design and methodology. Design considerations for different device parameters are explored. It is suggested that the relative improvement in device performance due to Fe negative capacitance becomes more significant in very short channel length devices because of the increased drain to channel coupling. Now comes to the methodology. Methodology is like QVG and IDVG characteristics of an F-type NCFET for two different VD. It is interesting to note that the hysteresis loops in QVG and IDVG can be dynamically controlled by drain voltage VD. It is due to the fact that Q and CMOS surges with the VD because of the electrostatic coupling of the channel to the drain. This together with the fact that the shape of the hysteresis is dictated by relatively magnitudes of CMOS and CFE means that the hysteresis in QVG and IDVG characteristics can be modulated dynamically by VD. Thank you.